Okay, we're gonna pretend that you guys are always on task for the next 10 minutes. And we're gonna go over the notes. Is it still recording? Can you see from there? Can you tell? Yeah. No? Stare at me. Okay. So, these are different ways that you can tell that something has no solution before you even get started. Okay? Or with doing very minimal amounts of work. So, a system will have no solution. You can tell with elimination if what?
If all the constants are the same,
Correct. If all of the variables match, but the constants don't. Do any of the variables match?
No.
No, there must be a solution then, right?
Yeah.
No.
Careful.
Have to multiply or divide and then multiply.
Yeah, we're going to have to multiply or divide. Would it be better to multiply or divide?
Divide.
But if I divide to make this smaller, can I divide this very well?
No.
No, I can't divide by 2 or 3. So let's just start this one by multiplying by what?
3.
How do you know 3?
Because 2 goes into 6 3 times and 3 goes into 9 3 times.
Perfect. So if we were to rewrite this, we would have 6x plus
9y.
9y equals
18.
18. And then this guy, we didn't have to do any work for. We got variables to match. The problem is what?
It's no solution.
These variables match and
Those variables match.
and these variables match, but these
don't.
don't. So that's your sign of no solution with elimination. With substitution, a good sign that we should even do substitution would be what?
You have to get y equals.
There's either a y equals or an x equals. See how the equal signs do not line up? Elimination is not ideal here. So if I know that this is what y equals, then I'll put it in for y. So we'll say negative x plus, but instead of writing y, I'll say x plus 2 equals 4.
But the x is at
But what happens here?
0.
They drop out and we're left with 2 equals 4. Is that true?
No.
No. Another reason why that would be no solution. Before I even started graphing the last set of equations, how could I have just stopped there and said no solution without graphing?
Same slope, but different y interval.
Yes, where did you get that language?
My head.
Oh, wow, it looks an awful like what I wrote. Awesome. Okay, what's the slope of the first one?
2x.
Yep, that 2 is the slope, right? Okay. What's the slope of the second one?
4. Wait.
2.
No, it's 4x. It's right there.
It's 2.
It's 2.
It's 2 because you divide everything by 2 to get y equals, and 2 divided by.
We'll divide, you want to divide, well, let's be careful with that actually, because I'm not going to do that yet. Let's solve for y first.
Okay, so we got 4 on both sides, then
Okay, let's do that. We'll move the x first. So what's on the left side?
2y.
Negative 2y is equal to
4 at negative 4x plus
negative 4x. That's a terrible x down here. Plus 16.
Now divided by negative. Can we do that?
Yes, we can. That's why I didn't want to do that right away. I didn't want to be left with that negative y. That confuses kids. Negative 2 divided by negative 2?
Y.
1. Y. Very good. And negative 4 divided by negative 2?
Positive 2x.
And 16 divided by negative 2?
Negative 8.
So how do we know that this will be no solution?
Because the slopes are the same.
Slopes are the same, but
The y-intercept is different.
they're going to start at different spots. Yep.
So if you were to end up with a negative y and then equals whatever,
Mhm.
would you just multiply everything by negative 1?
You can do that, or you can divide by negative 1. Either way, yes. That's the perfect solution in that scenario. Okay, we were behind yesterday. I really don't want to rush you, but I want to talk through these at least. Notice I said at least. Okay, the instructions say on this set of notes to do what? Choose your method. So now we're going to choose between elimination, substitution, and graphing based on which one makes the most sense to do. It's not about picking your favorite method, it's about picking the one that's going to do the least amount of work. So with this first set, what would make the most sense? Elimination, substitution, or graphing, Carly?
Elimination.
And what's the sign that would be the case?
Because if you times everything on the bottom by 4, it would be equal to the top. If you divide the top by 4, it would be equal to the bottom.
Perfect. What's another sign? Yes.
The equal signs meet up.
Yep, the equal signs already line up. What about the variables? What do they have to do?
Divide.
True, but they have to line up also. Right, Devin?
Yep.
Awesome. Would you rather multiply or divide?
Divide.
Divide.
You'd rather divide?
Yes.
Yeah.
By 4.
Okay, are they all divisible by 4?
Yes.
Yes.
Okay, so that'll work out. Let's divide. Okay, 12 divided by 4?
3.
We'll tack an X on there. 8 divided by 4?
2.
We gotta
Negative
carry down that
2y.
minus, yep. Negative 4 divided by 4?
Negative 1.
This guy we can just rewrite.
Negative 3x.
Negative
Plus
3x,
2y.
positive 2y
Equals.
Again, I need to, my x's have to be on top of each other, the y's and the constants. Which one of these match perfectly?
The 3's.
All
the
of them.
x's and the y's.
Almost match perfectly, right?
Well,
They all happen to be what?
Negative and
different
positive.
thingies, different things.
Opposite signs. Would we add or subtract these then?
Add.
Add. So we have positive 3x, positive. Okay. 3x plus a negative 3x.
Can we cancel out?
That's 0. Negative 2 plus a positive 2.
Cancel out.
Cancel out.
Giving us 0 every time. Negative 1 and a positive 1.
Cancel.
It's infinite solution.
How do you know it's infinite and not no
Zero.
solution?
0 equals
0 does equal 0. That's an okay thing. So we'll say infinite. What's another word for infinite solutions? What else might you see?
All.
Many solutions, all solutions. Yep.
What about infinity solutions?
Sometimes they say infinitely many, which is like a little redundant, but we'll see that sometimes.
I don't do that.
With this next one, which method would make the most sense? Elimination, substitution, or graphing? Just so the other class knows there's people with their hand raised, but I want to hear from more things. Derek, why? Yeah, these do not line up. In order to make them line up, you have to do a lot of work. Who likes doing extra work? That's what I thought, besides Devin. So, he did raise his hand. I'm not just calling him out. So, we have an equal sign here. Do our x's and y's, are they on the same side? No. So, if I already have a variable solved for, then let's take it and put it into the other equation. Is step 1 done?
Yes.
Yes, that variable solved for. Yay, less work. Step 2, that's when we have to actually substitute. So we have 3x plus 2 times y, which is negative 3x. And that equals?
Negative 4.
Negative 4. I think it's still recording.
I can't see the button.
There should be like a timer up at the top or on the bottom.
I think it's on the bottom.
Don't mess it up though.
I don't have a lot of storage, so I don't know.
Still recording. It's at 10 minutes.
Time flies. We're having fun, right, guys?
You're not in the camera right now.
Good. Can I do parentheses first? Can I combine these?
Yeah.
No.
How come I can't?
Because they don't both have variables.
Yeah, this has a variable, this doesn't. They're not friends, right? So the warden's going to have to come in individually and take them out of jail. So this 6x is hanging out here waiting for his buddy to get out. We have 2 times negative 3x.
Negative 6x.
Very good. And the warden comes in here and gets this guy.
Plus 8.
Plus 8 equals
4. Negative. It's supposed to be negative 4. Yeah.
Oh, thank you. Thank you.
No solution.
Why is it no solution?
Because of the 6x
The
and
x's
6x.
cancel out and 8 does not equal negative 4.
The 6's will cancel. And 8 and 4 do not equal each other. So it's no solution. What would this look like if I graphed it?
Be parallel.
Parallel lines. Very good, Devin. What would this look like if I graphed it?
They would be on the same line.
They'd be on the same line. You'd have the same line that you're trying to draw twice. They'd meet forever because they're on the same line. That happens on your homework. This one gives you a suggestion instead of choosing. It says rewrite the system in slope-intercept form to figure out how many solutions they have. So we're going to practice that. What's slope-intercept form again?
Y
Y equals
Is the first one in y equals?
No.
No.
None of them are.
None of them are. In fact, we're like, yay, elimination. Oh, can't do it. Allison says. So this guy has to be by himself. How do we start?
Subtract 4 on both sides.
Subtract 4x on both sides. I haven't, you have to be really, really careful with this. We have a negative y left over. That's a pain. But you gotta watch for it. You can't just like, we'll just make that a regular y. Can I combine these? No,
It's
they're not
negative
friends.
4x minus 6.
Now what Morgan was asking earlier is if you are stuck with a negative y, what can you do about it? Yes?
Divide by -1.
You can divide by -1 or
multiply.
multiply by -1. That is totally up to you. Her suggestion really was multiply, so we'll multiply, but Mason is totally right as well. What's -1 times 1?
Wow.
Oh, excuse me, haha, trick, I got it wrong. -1 times -1?
1 or y.
1y, yep.
4x.
And -4 times -1?
4x.
And -6 times -1?
6.
Okay. You could also view it like this. If negative y is -4x and -6, then positive y must be +4 and +6. This guy, x plus y equals 6. Now what?
Minus x on both sides.
Y equals -x plus 6.
All right.
It's going to be
So just by looking this, how many answers will there be?
1.
How do you know one?
Because the
Because
slopes
the
are
slopes
different,
are
but
different.
the y-intercepts are the same.
Exactly. The slopes are different, which means they're not parallel, and they're obviously not the same line because the equations look nothing alike. So what happens is every time I introduce to you guys, hey, sometimes we have no solutions and infinite solutions, and then I give you